Hello, ladies and gentlemen. Welcome to yet another exciting lesson from SAGET Tech. My name is Asaf, and I hope you enjoy this one. But please, don't forget to hit the subscribe button below this video for us to be able to keep on producing more and more of these wonderful lessons. Today's lesson is based on the grade 7 technology, term 2, and the topic is stiffening and strengthening of structures. Let us straight away start with the stiffening of materials in order to make structures very strong. And in this regard, stiffening refers to the processing of materials to make them rigid in order for them to be suitable to be used in structures. With rigid, we refer to making materials strong enough not to easily bend. There are, of course, a number of methods that are used or employed in order to stiffen materials, and the first method is tubing. We use tubes in very different occasions. I think in electrical wiring we use PVC tubes through which we run wires, and we also use tubing in water systems where they make PVC water pipes. And in this regard, let's look at tubing of steel or steel tubing. These steel tubes are usually used in major constructions where we make big buildings. We first have got to start with the frames of such buildings, and the frame are made of these strong tubes or steel tubes. We also use steel tubing in construction of bridges. The tubes can be made in different shapes. The first shape is round. There it goes. I think this is one of the most common ones. They can also made triangular. Those are the triangular type of tubing. We've got the square tube, and we as well have the rectangular tube or tube. The second method of stiffening of materials in order to make a very strong and rigid structure is folding. And we refer to folding as a repeated rolling of a sheet of plate or paper in order to make it rigid. I think you would recall how our grandfathers used to roll paper in order to make a tobacco cigarette. They would just roll paper repeatedly, so put tobacco inside and light it on the other side. Imagine if the paper was too light. It was going to burn faster than the tobacco, and at the end of the day, the tobacco was going to be left uncovered. Now, they needed to roll paper repeatedly so that the paper and tobacco burn at the same rate so that they can enjoy their smoking. Now, the other examples is making paper dowels through folding. Making this paper dowel, we put a piece of iron, long iron, can be a very long nail, inside paper, roll paper on top of the piece of iron, then remove the piece of iron. Then we remain with the folded paper, and we call it the paper dowel. We can even use a stick dowel, put it inside the paper. You just start by putting it the corner of a rectangular paper at the center or the middle of it can be the piece of iron, a nail, or even a stick dowel, and start rolling it. And the thing is, you must roll it very firmly for a dowel to be very, very strong. And keep rolling it until you finish. And then you'll be left with one piece of paper flipping out, and you tie it to the entire dowel with a piece of sellotape, as you can see demonstrated there. Now you are remaining with nice, beautiful paper dowels. And your paper dowels will always be strong towards the center, because that's where most of the repeated folding came, and it becomes a little bit weak towards the ends. That's why it's important to cut the ends off. We, of course, have different uses of these paper dowels, but for technology pet project, we usually use it to make structures. There is our grade 8 pet, and this pet, I think it's the mining headgear. It looks like a mining headgear, then is a mining headgear. Yeah, and in our everyday life, the practical application of folding is the making of toilet paper roll. Very interesting. This is how they look. Toilet paper is rolled on top of this toilet paper hardboard roll, and this roll was made through folding. Let's check the roll when it is unfolded. You can clearly see that it was folded straight from the edge, exactly the way we are doing our very own paper dowels. But with this one, because you've got to put your hand inside it when you unroll the toilet paper, they made it a little bit larger than the ones that we have when we are making our paper dowel. The third method of stiffening is corrugation, which is the repeated bending of a sheet to make it rigid. You keep bending it to make it very rigid. And the typical example is the corrugated iron or the corrugated zinc. I think the most one that we use is zinc. And I've seen that used as well in asbestos roofing, but most commonly used one is the corrugated zinc sheet used in house roofs. There it is. It looks like this. It's not made like this in order for, to decorate it or just to allow water to drip down. No. Repeated bending of it make it stronger than when it is just a flat sheet. Corrugation is also used in hard card boxes. In order to stiffen the cardboard or to make it hard, you repeatedly fold it, or you repeatedly bend it in actual fact, and it becomes harder than when it's just a plain sheet. Let's look at it. I think it's clear enough to you that we put, the way they make it, you put a flat sheet and start repeatedly bending the other sheet and glue it to the flat one, and then you put a flat one again on top. Now it gives you a very, very hard cardboard that we usually use to contain materials. This is the completed hardboard that we use. Most of us have just seen this hardboard, but you don't know what's happening inside. It was corrugation that was used inside in order to make this very, very hard. That is why cardboard containers are usually used to carry very heavy loads without breaking. Now we get into the strengthening of structures. Remember, we have folding material that are used to make structures. Now that we've got those materials that we're going to be using to make structures, now we make the structure, but then we need to employ methods in order to strengthen these types of structures that we're going to be making. And we've got two main methods of strengthening structures. The first method is called triangulation. And if you look at this kind of a bridge, this is a bridge called the truss bridge, and it's made of triangles. These triangles are not there for decorating. These pieces of metals that are made into triangles are not just used for decoration, but they are just used to ensure that the stress is distributed evenly throughout the whole bridge. Because if stress was going to be centered at a certain point and not evenly distributed throughout, the bridge would easily collapse. Then we use this triangulation in order to evenly distribute stress throughout the whole bridge so that the bridge becomes very strong and rigid. Now, the second method is the method that is called cross bracing. We cross the pieces of iron, as you can see on that particular windmill. Never mind the blades that are rolling. Look down there on the frame of the windmill, and you'd realize that there are pieces of iron that are being cross-braced there in order to make this windmill or the structure of the stand of the windmill very, very strong. Now, we get to the method that are used to make the structure very stable. You'd recall, if the structure is not stable, it's easily blown away by wind, it can bend. So we need it to be stable and grounded so that it does not collapse. What are the methods employed here? We've got three main methods that are used in order to make the structure stable. The first one is we need to make the base wide. Let's look at it. The wide base, just at the bottom, the base is very wide and the top should be very narrow. I think you can see that our base is wide, the top is narrow. Now, for graphic communication learners, you might think that there at the base is your station point, and there at the top is your vanishing point. No. This is the actual thing. It does not matter. You can measure the base and climb up the ladder and measure the distance right around your top. You'd realize the top is very narrow as compared to the base. I think even with a windmill, you'd realize that, you'd appreciate that at the bottom it is very, very wide. But as you climb up to the top, you realize it's very narrow. That's one method of making this particular structure very stable. The other method employed here is to make the structure as low as possible, the height of the structure as low as possible. This can be very, very confusing to some of the learners. Now we need to explain it and you listen very carefully. I know one would say, but you look at the cell phone tower, it's very, very tall, but you want to say it's made as low as possible. Look, if you want the reception of the phone to be very, very excellent, you need to make a very, very long cell phone tower. But then again, you stand at the risk for that to collapse or to bend or to be easily affected by wind and be broken if it's too long. Now, what is made here is they start erecting the cell phone tower, but immediately when it starts to give us a signal, they stop there. It does not have to be more than an excellent signal, go very, very, very high, because they know if they put it very, 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 very high, or they build it very, very high, it stands at the risk of collapsing. The same thing happens to the water tank stand. You know, if you make a very, very tall water tank stand at the risk of collapsing, because now you'd recall the water tank, it's there on top of it and it's so heavy. Some are 5,000 liters, but some are 10,000 liters. So it becomes very, very, very heavy when it is full. So the structure must be as low as possible. Being as low as possible, meaning that for as long as at that particular point the pressure is enough to push water to get inside the house and up to your geyser, then it's fine. You don't have got to put it very, very high up there so that the pressure is very, very... For as long as there is a pressure that can bring water inside the house, then you stop. You don't have got to make it very, very tall. That's the meaning of making a structure as low as possible. Then the last one is to make the top lighter in mass and the base heavier than the top. The top should always be lighter in mass than the base. You'd just imagine if the top of any kind of structure is heavy compared to the load. No. The structure it's easily going to collapse. It won't be stable. Any kind of maybe wind or anything that would come, it would make it collapse. Ladies and gentlemen, that is strengthening and stiffening material. Now let us make an activity in order to check as to whether we understood the different methods of stiffening and strengthening of materials or of structures. Now, make a paper table using methods of stiffening as well as strengthening. The height, the length, as well as the breadth of the table should be the same and equal to 150 millimeters. The tabletop to be made of corrugated paper attached to 2 sheets of paper on either side. The method of strengthening the table should be triangulation on one side and cross bracing on the other side. Now, the last thing is you need to make the legs to that particular table. And the legs, it can be made of round tubes of paper or rectangular or triangular or square tubes. You can also use folding in order to make the legs of the table, where you use paper towels. So, are you able to do that? You can pause this video and do that. Upon completion, now you can go and look at the examples that people that I was working with came up with. These are the possible answers that we came up with. These are 4 tables that the group of people that I was working with were able to make. The bottom table, you see this side, it's a cross bracing, and the legs are triangular. It's very difficult sometimes to make triangular legs. That's why they become so thick. But look at the top of the table. It is made of corrugated pieces of paper with flat pieces of paper on top and underneath. The second type of a table, there it is. This side that we're facing, it's 2 triangles, and that other side is cross bracing. But then the legs, interestingly, are made from folded pieces of paper, which means they are paper towels. And if you go up again, the last but one, it's made of rectangular kind of legs of the table. And the side that we're facing, I think that is the strengthening. It's a triangulation as well. But now look at the top one. That is an attempt to make square types of folding. I think they made a very good attempt of folding. But the top, very interesting, it's made of corrugation. If we can do this, then clearly you have understood how to apply these different methods of strengthening and stiffening of structures. From me, Asaf, thank you very much for listening. And if you want to get more of this lesson, keep coming back to our YouTube channel, SAGET Tech. And if you hit the subscribe button just below this video, you're giving us a chance to keep on producing more and more of these lessons for your better understanding.